All right, so let's give this a shot. My iPad was not working with me, so what I'm gonna try to do is record this screen as I type some notes here on your first page of the yellow toolkit. So this toolkit is for chapter 12, and you will be taking a quiz on it on Fridays. So please be prepared. We are going to go over fundamental counting principle. We're talking about the event of, I think it's if one event has n possible outcomes and a second independent event has n possible outcomes, then there are m times n outcomes for both events to happen. And then a factorial. So there's a quick little thing for you guys to know, especially going into integrated math 3. You really need to know this. That little exclamation point is not trying to make you say an excited for, like for. No, it's for factorial, okay? It's not an excited for factorial, promise. All right, so permutation and combination we will do tomorrow. We're not going to try to tackle all of that in one day. So today we're just going to do the front. All right, so fundamental counting principle. You will use this in integrated math 3. I have observed classrooms where she's doing this with the students. So don't you dare act like you've never heard of it before. Here's an example. A decision chart is useful, and actually, it's not even up here on this screen. Awesome. Okay, so we're missing a picture here, but you should see the little chart. So it says here, how many 3-letter arrangements could be made by lining up in a 3 blocks, chosen from a set of 26 alphabet blocks if the first letter must be a vowel. So we have to think of how many vowels there are, right? So A, E, I, O, U, sometimes Y. So in this case, it does not count it. All right, so if we know the first letter is a vowel, and there are 5 vowels, let's see here, add a little text box. Okay, if there are 5 vowels, then I'm going to put a 5. Okay, or we can even put parentheses 5, because we're going to be multiplying. And then 25 for the second, so there are 25 choices, and 24 choices for the third. We got 5 because there are 5 vowels in the alphabet, right? Okay, so since there were 26 alphabet blocks, as soon as we pulled from the vowels, we're only left with 25 letters, right? And then after we pull another letter, we're only left with 24 letters. So we have to do 5 times 25 times 24, and you should see on your paper it's 3,000. Okay? All right, so for the second one, how many 4-digit codes can you create from the number 0 to 9 with no repeated numbers? All right, so 4-digit codes from 0 to 9. Well, okay, first let's show you how many numbers are there from 0 to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's not 9 numbers, right? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So, let me make this a little bit bigger. So our first option, which again I should have put some parentheses because we'll be multiplying. First option for our first digit, right? So that's where your little chart might come into play, nice and handy. So if I were to move this, we can add first digit right here. So our first digit, there are 10 options. But once we've pulled one of those digits, right, we are only left with 9 numbers left, right? So I'll just call this second digit. And then once we pull that, we are only left with 8 digits to choose from. Let me try to make this smaller here. No, it makes all of it smaller. Awesome. Learning as I go here. Okay. So the 8 is our third digit option, right? And then our fourth digit option, there's only 7 numbers left to choose from. Okay. So this is the fourth digit option. There's only 7 left to choose from. So here, really, let me just rewrite this a little bit nicer for you. 10 times 9 times 8 times 7. Oh dear, let me get out my calculator here. So that would be 90 times 56 will give me the probability, or how many combinations I could have. I'm so sorry, not probability here. How many possible combinations I could have of 4-digit codes, and this is why we use codes for everything, because here, from the number 0 to 9, there are 5,040 possible codes. That's awesome. And we found that out just by knowing we cannot have any repeating numbers. If we could have repeating numbers, it would be 10 times 10 times 10 times 10, right? Because we could choose from any of those 10 digits because it doesn't matter if it repeats. But here, it does matter if it repeats. So it would be 10 times 9 times 8 times 7 because we cannot use the first digit for the second or the second digit for the third, etc. All right. So 5,040 is your answer for part A. Now here, this one gives you everything, right? We don't have to try to figure out how many vowels there are in the alphabet. Here it says if you have 5 shirts, 3 pants, and 2 skirts, how many outfits can you create? It's as simple as doing 5 times 3 times 2. At this point, I ask you, what is that? You should be able to tell me. You can create 30 outfits from that number of clothing. Okay? That's that. All right, factorials, pretty simple, all right? 0 factorial is always 1. That is a key point here, okay? Sorry, guys, I'm tired. All right, 0 factorial is always 1, always, okay? Just keep that in mind. Kind of like how any number to the exponent of 0 is 1. 0 factorial is always 1. So here, 4 factorial would be 4 times 3 times 2 times 1. So you would just multiply the first number by every number that's below it. Or 4 factorial is 24, right? So for 8 factorial, you'd want to set out 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And really, your calculator should have a factorial button, but you guys need to know how to expand it out as well. Let's see here. All right, let's multiply this out. So you guys should do this on your calculator too. See if you can find the factorial button for 8. So it would be that exclamation point. Remember, don't shout 8. It's just 8 factorial, not 8 exclamation point. 8 factorial. Okay. So I know I see it on Desmos. It's underneath function. Just check that out for you because I don't feel like multiplying all those numbers. I doubt you do. So 40,320 would be your answer here. That is what 8 factorial is. Okay. This guy's written all wrong. So you know what we're going to do is just create a new one here. So it's going to be 10 factorial, and that is over, let me just underline that. Okay, I improvise here a little bit. That is over 7 factorial times 3 factorial, okay? So I think your guys' is fine, but my little PDF here is all wacko, so. All right, so this guy, you guys would want to expand that out, top and bottom. All right, so if I were to expand this guy out, right? So this, oh, geez Louise. All right. So this is going to equal 10 times 9 times 8. And then would you looky there? Whatever is left is technically 7 factorial, but let's go and multiply it out just so you guys can see it. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And then down here, if I were to expand that out here, I'm going to line it up because I know what's going to work here. I'm going to have 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1 And then my 3 factorial would, and we're just going to throw it over here on the side, would be 3 times. Alrighty, so my last video cut me off before I was ready. But basically, the last video ended with me, oop, not that one. Hold on, sorry. Ended with me beginning to say to, oh my goodness gracious, I'm too tired for this right now. This is being a pain in the butt. Hold on, guys. All right, well, right here, these guys, those right there, 3 times 2 times 1, right, was the 3 factorial. There we go. All right, and right beside it, all these guys are the 7 factorial. And look at here, all these numbers match up. 7, 6, 5, 4, 3, 2, 1, right? We can cancel all those out. So cancel them out. Okay, that's what that says, cancel out. And then all we're left with up top is 10 times 9 times 8. And on the bottom was 3 times 2 times 1, right? So then I simplified it out. 10 times 9 times 8 is 720. 3 times 2 times 1 is 6. 720 divided by 6 is 120. So 120 is equivalent to 10 factorial divided by 7 factorial times 3 factorial. Okay, we get 120. So it's all about simplifying. Sorry guys, I'm exhausted. Moved my grandma today. Tired. All right, so let me go ahead and click over to this worksheet. All right, this is your work for today. It'll go pretty quickly, hopefully. Okay, so here I see the top half is all the FCP or fundamental counting principle. A car model comes with the following choices: 9 colors, with or without air conditioning, with or without sunroof, with or without automatic transmission, with or without a spoiler, and with or without anti-lock brakes. In how many ways can the car be ordered? Well, first I want to see, I know right away I have 9 color options, right? And then I also have, let me go and change my color here. So I have 9 color options. And then I have, let's see. And then I have with or without air conditioning. So it's either with or without. So there's 2 options for AC. There's 2 options with or without sunroof. 2 options with or without automatic transmission, with or without spoiler, and with or without anti-lock brakes. So once you guys multiply that out, that is how many ways the car can be ordered. Okay, so it's a lot of logic just being put in, like, okay, how many choices do I have? That's the number I'm multiplying, right? Same thing here. You're about to take an 8-question multiple choice test. Each of the questions have 4 answers. So literally, if you have 4 answers each time, 4 times 4 times 4 times 4, 8 times, right? 8 questions, 4 answers. So how many ways can you answer the test if you leave an answer for each question? So none of the answers will be left blank. You have 4 choices every single time. So you guys should be able to do these. They're kind of like the examples, the 0 to 9 one, okay? Factorial, again, you expand by writing 4 times 3 times 2 times 1, etc. You can use a calculator for some of these. I want you guys to try to like figure out how you can cancel things out. So like this guy, I would end up writing 78 times 77 times 76 times 75 times 74. And I'm going to stop there because then I see on the bottom I have 73 factorial. That's the same thing as this bottom here, right? 73 factorial. So you can cancel out the whole factorial, right? And then you notice all you have left is just to multiply these 5 numbers here. Okay, so that's all you would have left. So that's how I would write out that problem. Because 73 factorial would just be us multiplying 73 times 72 times 71, etc. Right? So just cancel these 2 guys out. These 2 would just disappear. And then you'd be good to go to calculate just that product. Okay? So, I mean, hopefully this helped you guys out a little bit. Message me if you have any questions. You guys are taking a quiz on this on Friday. Okay, we're learning 2 new things tomorrow, so be ready for that. All right, so be ready for that quiz. Okay, see you guys tomorrow.